Now we'll start now individually focus yourself because now we have nearly 3 hours. So focus yourself individually, and these 3 hours, stay with the lesson. Don't stay with whatever your personal issues going in your brain, going inside your mind. So while listening, don't you think about what's happening in your house. I don't know whether still my people sleeping. Don't think anything personal things in your mind. Just leave everything outside your mind and focus yourself for the 3 hours. Only 3 hours, right? You can focus for 3 hours, like watching a film. The time duration for a film is also 3 hours. How you pay your attention completely to the film to understand the film? Because if you missed one part, you don't understand the climax, what's happening. So therefore, in order to understand the story properly from top to bottom in the film, you pay your attention. In the same manner, pay the attention for this lesson as well. Assume physics is a film, you are viewers. Then definitely you will feel physics as a film. Okay, very interesting film. Very interesting than the films. Okay, right? Am I right? Okay, right. Okay. Now, currently we are learning about normal reaction force. Now, for your syllabus, now we are learning gravitational force, already discussed. Then we just started normal reaction force. We want to learn many things under normal reaction force. Very important force. It's very, very important. They can ask plenty of questions from normal reaction force in different manner. Very confusing as well. Okay. After completing normal reaction force, today our plan is if we can go to tension forces, we are learning tension force as well. Then compression force, finally friction force, right? Okay. Then normal reaction force. Already I explained what is this normal reaction force. Normal reaction force. Notation of normal reaction force is capital R. Okay. Normal reaction force means due to the compression between two surfaces. When you place an object on top of another object. For an example, let's say now you are placing this phone on the table. So table is an object. My mobile phone is also another object, very valuable object. Very valuable object. So when you place an object on top of another object, when there are two surfaces, in that case, bottom surface of my mobile phone, top surface of the table, they are in contact with each other. And also you know that because of the weight of my mobile phone compresses the surface of the table. So let's say this is my table surface of the table. Surface of the table. Table. This is my mobile phone, an object. When there are two surfaces in contact with each other, due to the compression, there are forces generated on the surfaces. We call those forces as normal reaction forces. For an example, now this object compresses the table downward direction. So this object produces a force on the table. Which direction? Downward direction. We call this force as normal reaction force. This is normal reaction force. Normal reaction force. On whom? On the table. By whom? By the object. Right? When someone compresses you, when someone pushes you, you won't stay like that, okay, push me, I fall down. You never do. If someone pushes you, you also push him back. Definitely. If someone hits you, hit me, it's okay, fine. It's okay. You like to hit me, then hit me, slap me. So you never do that. And if someone hits you, you hit you. You hit you. You hit him. You hit him. The same manner, when this object compresses the table, when object produces a force on the table, according to Newton's third law, every action has equal and opposite reaction. A table also produces a force on the object. This is also normal reaction. Normal reaction force produced by whom? Normal reaction force. Okay, on whom? On the object. By whom? By the table. This is the idea behind normal reaction. Simply, normal reaction means when two surfaces in contact and due to the compression, there are forces formed perpendicular to the surfaces. We name those forces as normal reaction forces. All right? Okay. So then we finished, we explained that part. I revised it again. Okay, we'll put a topic. Put the topic and write down. Topic. It's not a topic. It's a sentence. Write down like this. Let's consider an object of mass simple limb. Let's consider an object of mass simple limb. Let's consider an object of mass simple limb. Let's consider an object of mass simple limb kept on a horizontal, smooth, horizontal, smooth table. Kept on a horizontal, smooth table. So case one. Okay. Right. Now this is your table. This is your table. Now they have clearly mentioned horizontal table. Okay, all the tables are generally horizontal. Why they have mentioned smooth table? Because all level also you learn science. Ne? When table is rough, your surfaces become rough, then we want to consider frictional forces as well. Still, we didn't learn friction forces. Therefore, we are assuming table is smooth. Smooth table. Smooth. Okay. Then just now we learned that normal reaction forces form on the table downward direction capital R. Normal reaction force on the object upward direction capital R. In addition to this force on the object, what is the other force acting on the object? A normal reaction force is acting on the object. What are the other forces acting on the object? Other forces? The weight force, the gravitational force, weight force acting on the object from the center of the gravity of the object downward direction. Weight is mg. Let's say mass is simple limb. Simple limb. Okay. When we look at the object, there are two forces, normal reaction capital R, weight force mg. We can understand when you place an object on the table, object is at rest. Then what can you say about the weight and normal reaction forces? What can you say about the magnitude of the weight and normal reaction forces? If I separately mark the forces on the table, forces on the object. Forces on the object. Currently, this is our object, beautiful object. Weight force is mg. Normal reaction force capital R. Now you can understand your object is at rest. Your object is not moving. That means, what can you say about the magnitude of capital R and the magnitude of mg? They should be equal. As object is at rest, upward forces should be equal to downward forces. Therefore, R equals mg. Now you learned what is normal reaction force. Now According to this example, normal reaction force equals to weight of the object. Most of the cases, normal reaction force equals to weight of the object. But that does not mean that always normal reaction force equals to weight. Understand? Hands up who understood what I told right now? You understood, Neil? You understood? Okay. Write down this beautiful diagram and this beautiful note. Quickly. We don't have time. We don't have time. Okay. Yes. After case 1, draw this diagram and write down everything. Okay. Good afternoon. Good afternoon. Even if I say good night, you would say good night. Good night. Good night. If I was a hi. Hi. Why don't you come front? No need today. You stay. Quickly draw the diagram and mark the forces. Quickly. Now January onwards, my plan is I am extending the class time duration to from 3 hours to 4.5 hours. I think all you are excited. Every week, exciting weeks. We are learning physics for 4.5 hours. It's very interesting. It's like, as I mentioned before, it's like watching a film. Now, at the end of a good film, you feel very sad because film is gonna end. But because of that feeling, I thought of increasing the time duration as well. Then you can watch a film because physics also, I told you, like watching a film, you can watch this beautiful physics film for 4.5 hours. Like a series, TV series. January onwards, plan is 4.5 hours. Okay. Otherwise, we can't do questions and I need some time. Quickly. Right, finished. Case 2. Okay. You are laughing. You are very happy to stay in the class. So cold. So you brought the AC remote. Uh, 26. 27. Okay. Okay. Right. Finished. Okay. Right. Finished. Time is enough. Okay. Okay. Now I'll erase the board. Right. Okay. Right. Now case 2. Case 2. When an object is placed on the earth. When the object is placed on the ground. Case 2. Write down. Case 2. Case 2. Object is placed on the ground. So this is the surface of the ground, if not earth. Now this is your object. This is your object. Okay, your object. Okay, quickly mark the forces. Whatever the forces that you learned, quickly mark all possible forces on the object as well as all possible forces on the earth. Let's assume center of gravity of the earth is somewhere here. This is the point, center of gravity of the earth. Center of gravity of the earth. Quickly mark down all the possible forces. Quickly. capital G, center of gravity of Earth. Let's say GE. If you need GO, center of gravity of the object. GO, center of gravity of the object. Then what is GE? Center of gravity of the Earth. Of the Earth. Okay. Now quickly mark down all possible forces that you learned. Now currently we only learned gravitational force and normal reaction force. So it's not a difficult thing. Right. So we know that weight force, gravitational force, weight. Let's say mass of the object is simple m. Gravitational force mg. Right? This mg means what? Gravitational force on the object. Every action has equal and opposite reaction force. This is the gravitational force on the object by the Earth. Then what is this? Then what is this? Carefully understand. Listen. Simple mg means what? Gravitational force on the object by the Earth. Then what is this? Gravitational force on the Earth by the object. This is also mg. Okay. Mark down quickly. Gravitational force on the Earth by the object. Gravitational force. Quickly. Gravitational force on the object by the Earth. Quickly write it down because I can't give so much time to write down these things. Then just now we learned. Now there is a contact between these two surfaces, bottom surface of the object and the surface of the Earth. Therefore, there should be normal reaction forces. Normal reaction forces always perpendicular to the surface. Normal reaction force. Capital R. Capital R. Normal reaction force. And you want to understand this normal reaction force and weight. Both the forces should be in the same line. So if I mark this capital R exactly here, this diagram seems like kind of a mess. Therefore, I have marked in this manner. Okay. Then this is normal reaction force. Normal reaction force on the object. Yes. On the object by the Earth. Normal reaction force on the Earth by the object. This one, normal reaction force on the Earth by the object. Normal reaction force on the Earth by the object. Okay. Quickly. Okay, finished. Right. Now you are very familiar what is normal reaction force and you know what is gravitational forces. And what can you say about R and mg? Object is at rest, therefore R equals mg. R equals mg. R equals mg. Okay, important. Important. Important, and take your red color pen and write down like this. Like this. Important, and write down like this. Most of the cases, normal reaction force, normal reaction force equals to the weight most of the cases, normal reaction force equals to the weight, but normal reaction force is not always, equal to the weight. I think you can understand what I said, right? You can understand. Okay? Normal reaction force is not always equal to the weight. Not always. Highlight it. Not always. Most of the cases. Most of the cases. Not always. Write down. Okay. Right. Now, if we draw, okay. Now, if we are drawing the variation of normal reaction force. Now, let's say now this object is 5 kilogram object. Then what is the normal reaction force? If the mass is 5 kilogram, normal reaction force equals to what? Because gravitational acceleration is 10 ms minus 2. Normal reaction force means mg, 5 into 10, 50 newtons. Suppose your mass is 100 kilograms. What is the normal reaction force? 1000 Newton. That means when mass changes, normal reaction force changes. Quickly, you want to plot a graph. Y-axis should represent capital R. X-axis represents simple limb. Quickly draw the corresponding graph. Topic, the variation of normal reaction with mass. The variation of normal reaction with mass. Quickly draw the variation of normal reaction force with mass. The variation of normal reaction force with mass. Quickly. We know R equals mg. R equals mg. Quickly. Because we already learned graphs. Now we have very big knowledge in graphs. R equals mg means now variation of normal reaction force. Y-axis represents normal reaction. X-axis represents the mass, simple limb. Normally mass is measured in kilograms. It can be grams as well. Normally normal reaction forces measured in newtons. Newtons, a force, right? Therefore newtons, okay, right. R behaves like your y-axis. Y-axis, mg. Our x-axis is simple limb. So I write like this, R equals g into simple limb. R is my y-axis. M, x-axis represents the variation of the mass, x. Gravitational acceleration is a constant. It's a constant. So we can assume g as our gradient. G as our gradient, capital M. It seems like y equals mx graph. Y equals mx graph. Y equals mx graph. Case number 2. Case number 3. Case number 3. Case number 3. When a force capital F, when a force capital F is applied vertically downwards, on the object. Okay. No difference. You kept your object on the table. If not, you kept your object on the ground. In addition to that, you are applying kind of external force, let's say 5 Newton. You are pushing your object further. You applied capital F force on the object. This is the applied external force, capital F. It's a constant force. Now you keep on pushing your object by applying 5 Newton force. And now R equals what? But still, even you push the object, still your object is at rest. Then vertically upward forces should be equal to vertically downward forces. Then R equals what? If you consider the equilibrium, if not, as object is at rest, as object is at rest, what are the forces acting on the object now? Tell me. Normal reaction, weight, what else? This external force, capital F. External force. External force. Then please tell me, what are the vertical forces acting on the object? Vertical upward forces. Capital R only. Vertical downward forces, mg, downward direction. Capital F, downward direction. Now tell me, R equals what? R equals what? mg plus F. mg plus F. mg plus F. mg plus F. Very easy, nahi? Vertical upward forces should be equal to vertical downward forces. Now R means mg plus F. Now you understand. Normal reaction force is not always equal to weight. It changes depending on the situation. Draw the diagram beautifully. Hereafter, you are no need to mark the forces on the earth. No need hereafter. Okay, why we don't need to mark the forces on the earth? Okay, listen, okay. Listen, okay, stop, okay, right, okay. Okay. Now, previous diagrams, we marked the forces on the earth as well. Normal reaction force on the earth, weight force on the earth. But I told right now, 2 minutes before I told, no need to mark the forces on the earth. Why? Why? Why I told no need to mark the forces on the earth? We are not interested. Why? 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 Why we don't need to mark the forces on the earth? Why? Why? Because now currently we always, now object moves, so object accelerates, so if not we are lifting objects, so we are putting objects down, no. We do everything for the objects. Do we pull the earth? Do we what? Move the earth? So we consider earth is at rest. Therefore, all the actions that you do for the objects on the earth. So that's why we are interested forces on the objects. Do you understand? So hereafter, you don't need to mark the forces on the earth because we don't considering. If not, we are not interested with the earth. We are interested with the objects on the earth. If we apply forces, what will happen for the objects? If there's a chair, if I put a force, what will happen to the chair? I'm putting a force on the ground. I'm not interested. Understand? That's why hereafter we plot forces on the objects only. Got it? Hands up who understand that one. Who acts like understanding, hands up? No one. Okay. Now when you consider this object, normal reaction force on the object, weight on the object, capital F external force on the object. Mark down these forces and write down. Now combined maths, what you are learning now these days, trigonometry. Almost finished. Trigonometry is going to start. Chemistry, you need to start it. No, you need one. Now, which subject that you feel very difficult these days? Definitely, I'm pretty much sure easiest subject is physics. Definitely. Right? It's very easy. Very interesting subject is physics, right? Yeah. Even you say it's difficult, I don't agree. Even you say it's not interesting, I don't agree. Physics is easy and interesting subject. You must agree. So mark this capital R along this. Only hadanta ni kewa weight pasna igani ke twar elum dar pasna kelum line la elunga na line la varayella konna ungalku kannuku velangonu sutti pacheyum karupum pacha osakala karpa varanjalum karupu osaka pacha varanjalum karupu karuputhan. So you know because you can draw it nicely drawn. The reverse remote finished. So as the object is at rest, R equals mg plus capital F. Okay. Finished. Okay. Right. Okay. The variation of normal reaction force capital R. Again, we are plotting a graph. Now, what you want to do is, now what will happen when you increase capital F external force? Now, earlier you applied 5 Newton force. Now you are applying, you are applying 100 Newton force and you are compressing so much. Earlier you applied 5 Newton force external force. Now you are applying 100 Newton, you are compressing. Then what will happen for the normal reaction? Increases. Now what you want to do is, you want to plot a graph, the variation of normal reaction force with external force. Your y-axis should be R, x-axis should be capital F. The variation of normal reaction force with the external force capital F. The variation of normal reaction force with the external force capital F. Quickly. 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 Quickly write down. No need to speak. I think all of you can understand. No need to speak each other. So you can do it alone yourself. Very basic thing. I know you are sharing your knowledge with your friends. Yeah. Yes, I know that. But disturbing. I want to move here. Okay. What type of graph that you would observe? Y equals mx. Mx. Y equals what graph? TV, not TV. Still drawing. Okay. What graph y equals? Mx plus c. Hey, you have drawn y equals mx graph. You love so much y equals mx graphs. How you drew this one? Can you please show me the root cause of this graph? We are starting from an equation. What equation that you selected to draw this graph, madam? You want to select this equation, right? Without knowing the root cause, you are drawing. What about you? No. Ippe root cause kandupidikkringa. Okay, we'll come to there. Joel, what type of graph that you are? Still drawing. Still thinking you are. Madam, it's wrong. Your graph is wrong. Y equals mx graph. Wrong men. Wrong men. And now just erased and now just marked. Already, there are some marks of erasing. Purple color. Okay. Purple color. Okay. 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 Okay, right, listen. Okay. Now in this case, capital R, normal reaction force equals to, listen, okay, listen. Capital R equals to mg plus capital F. Now I mentioned we are going to understand the variation of capital R with F. When we are changing F, what will happen for R? Your x-axis is F, your y-axis is R. R, Newton, measured in Newton. X-axis is also external force. It is also measured in Newtons. Right? I can write R equals, I can move these two, capital F plus mg. Same thing, there is no issue. Then R behaves like Y, F behaves like X. This behaves like C. Y equals X plus C. Let's say in front of F, who is there? No one, blank is there. In front of F, there is 1. 1 into F, F. In front of F, there is 1. We can think 1 is the gradient. Simple M. Everyone can draw Y equals X plus C graph. If you don't know how to draw this graph, think 1 is M. Then Y equals Mx plus C graph. Please tell me what is your interception? Here is your interception. Interception value equals to what? Interception value equals to what? Mg. Then you must mark at the interception Mg. Mg. This is the graph. Very basic graphs. Case number 4. Case number 4. Same thing, but now, previously we applied the external force vertically downward direction. Now we are applying the force vertically upward direction. Case number 4. When a force capital F, applied, when a force capital F is applied vertically upwards on the object. Vertically upwards on the object. Vertically upwards on the object. Case number 4. Now quickly mark down the diagram. First of all, draw the diagram. Then mark down all possible forces on the object. Then get the equation quickly. Now you can do it. Right? Our object, this is our table or ground. An object is on the table. So when I mark the forces, yes, weight force is acting in downward direction, mg. Along this line, normal reaction force, capital R. Normal reaction force, capital R. Capital R. Now external force is also applied. External force is a vertical force, but vertically upward direction. And now this is my external force, capital F. But still our object is at rest. We are assuming even someone is applied a force in upward direction, still object is at rest. If this force is so much large, now you also have a sense, right? If you are applying this capital F force, if you apply very larger force, what will happen? Your object should move up. Now, currently we are assuming even we apply capital F force, upward direction, object is at rest. Understand? Based on that only, we are getting the equation. As the object is at rest, as the object is at rest, still, if the object is still at rest, means vertically upward forces should be equal to vertical downward forces. Now, what are the vertically upward forces? Capital R, upward direction, capital F, upward direction, downward forces mg. And now we can tell R plus F equals mg. In this case, R equals mg minus F. Minus F. Right on. SQ1 so sleepy, right? So this climate make us very sleep, right? Even we don't want to sleep, this climate make us to sleep, right? Why am I so sad? Something happened to you. What happened? A girl slapped you. You slapped a girl. Both of you slapped each other. No. Right, okay. SQ1, in above case, according to case number 4, according to case number 4, what is the minimum force given on the object? According to the case number 4, what is the minimum force given to the object, if not given on the object? What is the minimum force given to the object? To lose the contact between object and ground. To lose the contact between object and ground. Find the answer quickly. 2 minutes. To lose the contact between object and ground. Now you want to understand. When the contact between object and ground loses, what will happen for the forces? Then you can understand. Because we learned what is gravitational force. We learned what is normal reaction force. You know, if the contact between the surfaces loses, that means hereafter, there is no contact between object and the ground. Then what will happen? Based on that, find the minimum force, capital F. Answer how much? Found the answer, hands up. Who found the answer? No one. 1 second it takes. Found the answer. என்னமா கதை வாசிக்கிற மாதிரி யோசிக்கிறீங்க? எடுங்க டக்கு. Get the answer. Madam, when you are cutting, don't like baliguruti. Just cut by using only one line. I know you have so much pens. You like to waste the ink, but use only one cut. Do mean. Found the answer, hands up. Who found the answer? Who found the answer? You want to understand. You can use now. We are considering this case. Based on this case, I give that question. I am asking what I asked. According to the case number 4, what is the minimum force given on the object? That means they are asking capital F. What is the value of capital F to lose the contact between object and ground? Inside the bracket, no need. Okay. Okay. Understood. Okay. You should have a confidence on you. Okay. If you have confidence, you can hands up. Answer can be right. Answer can be wrong. Okay. Hands up. Who finished? Okay. What about you? Logic வேலைங்கதில்லை. என்னவா யோசிக்கிறீங்க? எடுங்க, ஆன்சர் எடுங்கடா கண்டு. No. What about you? No. No. Now there is no contact, man. There is no contact between object and the ground. If there is no contact means what can you say about normal reaction force? Zero. If normal reaction force 0, at least the force that you want to give should be equal to the weight. Come on. Listen. Right. Listen very carefully. Listen, okay, enough. Okay. All of you got the answers, very happy about you. Now listen. You know what is weight? You are feeling the weight. Now when you are standing, now when you stand like this, you feel the weight actually. You feel you are so heavy. You feel I'm so heavy, right? Why you are feeling you are heavy? Because you have a mass. Carefully understand, very important logic. Now you feel very heavy because of the mass, okay, because of something, you feel you are very heavy. If someone, now you let's say now, if you have a girlfriend, now sometimes you lift the girl, and you're holding your girl. In that case, you feel so much heavy. Am I correct? Because you are bearing your partner as well. In that case, you feel so much heavy. If someone is standing on you, you feel more heavy. You are feeling. Why you feel this weight? Why you feel weight basically? When you keep many objects on top of you, you are feeling larger weight. You feel your weight is so large. You feel weight because of what? Because of the mass. Hands up who says, if we feel the weight because of the mass. Hands up who says? We feel the weight because of our mass. Because of the mass only, okay. It's like this. Hands up who says, we feel the weight because of the mass. Because of the mass. Okay. Because of our mass only, we are having weight force. That's okay. I'm coming to tell. Yes. 25. 24. I think you came from future, I think. Because not yet started 25 classes. But very sure I'm starting class on future. I think you came from future. Back to future. No, you came from future to past. Yeah, according to him, according to me, he is coming from future. According to him, he came to the past. Am I correct? Right? Am I correct? Yeah, 25 classes. 25 class now current year is 24. 25 means huh? Current year is 22. oh, my bad. Sorry, okay. Now current year is 22. He came from future. Confusing, right? This future past time is confusing. Time traveler. No, normally time traveler is having side bag. It's normal bag. Right, okay. Okay, right, back to the theory. Okay, listen, okay, right? We feel weight because of mass. Because of the mass. Listen, okay, right, okay, listen, okay. Weight force, gravitational force, that means mg. That's true. I'm not talking about something like that. When you go to the space, do you feel your weight? You don't feel your weight, right? When you are in the space, you don't feel your weight. When you're floating, let's say now you are floating, something else, you feel your weight. You don't feel your weight. But when you are standing, when you are walking, you feel a weight. Why? Because of the normal reaction force. Sometimes you might have seen now you are getting to the lift. A lift. When you get into the lift, now lift is at rest. Now you want to go to 50th floor. Currently you are at the ground floor, if not first floor. Okay. Now when you get into the lift and very few seconds, I think maybe 2-3 seconds, you are feeling you are heavy. You might have felt that feeling. You are feeling you are very heavy. Then now lift is keep on moving upward direction. Now you've passed third floor, fourth floor. Now okay, now back to normal. Now no issue. Again, when you are reaching 50th floor, you are feeling very light. You are feeling you are very light. Because of what? Because of change in normal reaction force. Simply, normal reaction force. Because of the normal reaction only, you feel the weight. Okay. Do you understand? Normal reaction force generates by how? How normal reaction force generates? Definitely there should be a contact between two objects. Suddenly, if I lose my contact between the ground and me, what will happen for the normal reaction? Normal reaction force becomes zero. Do you understand? The question says that, what is the question? Read the question. What is the minimum force that you want to give, yeah, in order to lose the contact between object and surface? Okay. I will take some values and I'll show you. Now, let's say now currently mass of this object is 5 kilogram. Then what is the weight force currently? How much? 50 Newton. Okay. Now there is a normal reaction as well. So normal reaction force always not equal to weight, huh? Okay. According to this equation, we know R equals mg minus F. 50 minus F. Now you keep on increasing the force. Carefully understand. Carefully understand. You keep on increasing the force. Now let's say now initially you applied 1 Newton. Then what is the normal reaction force? 49. Then you're applying F is 5 Newton. Now you keep on increasing capital F force. Then what will happen for normal reaction force? Now force is 5 Newton. R is 45. Now F is 10 Newton. R is how much? 40. Now F is 30. R is how much? 20. F is 1. F is, let's say F is 49. R is 1. Let's say that. Let's say if your F equals to 50, then what will happen for the R? 0. If R becomes 0 means what happened to the contact between the object and the ground? There is no contact. Now object somewhat lifted. You understand? And then at least you want to give a force. At least you want to give a force equal to 50. Now, at least you want to give 50 Newton force to lose the contact. Now you are giving 100 Newton. What will happen? Definitely contact will be losing. At least you want to give 50. Minimum. You can give 51, you can give 100, but minimum you want to give 50 Newton. Therefore, summary is, if we want to lose the contact between two surfaces, at least your capital F should be equals to weight. Okay. So right, get the answers. Okay. Now hands up now everything is very clear. Very clear. Right. Draw the graph. Draw the graph. The variation of normal reaction force with the external force. Quickly. The variation of normal reaction force with the external force, capital F. Draw the graph. Hands up who understood when there is no contact between the surfaces R equals 0. We will write as a point as well. Quickly draw the graph, the variation of normal reaction force with the external force, capital F. Quickly draw the graph. In that case, again now, R equals mg minus f. I can write down R equals minus f plus mg. Now in this case, R equals minus f means minus 1f, right? Plus mg. R means my y-axis, right? Negative 1 is my gradient m. F my x-axis. Mg means my c. I am getting y equals minus mx plus c graph. Minus mx plus c graph. R minus mx plus c graph. How we draw minus mx plus c graph? We'll see quickly. Minus mx plus c graph. Aha, Varani. No, ye. What are you upset? Madam, mark down those things as well, okay? How we do as a note, okay? Where mean graph? In a phase of varel, done. Y equals minus mx plus c graph. Minus mx plus c graph. This is your minus mx plus c graph. You know how to draw these graphs. I'm not explaining these things. Interception equals mg. Interception equals mg. Okay. Okay, listen. Okay, listen, okay. Now I'll ask from someone. This value equals to what? Who would like to answer? Nada, madam. This value equals to what? Madam, this value? So can't see the board because of this disturbance. Madam, can you see this point? This value equals to what? Eh? Shall I come closer to you and listen what you said? Huh? 0. Madam, 0, see now, x-axis, it has a length, right? X-axis, this point is on x-axis. It has a length. How this length can be 0? Priyan inga, Prem, P ni. Prem, this value equals to what, Prem? Thinking. Pi. How much? Mg. Why it is mg? Why it's mg? By looking at the graph, how you came to a conclusion there is no contact between object and graph. Everyone listen, okay, listen, this is very important. If not, I don't ask the questions. I don't waste my time. I can directly teach, I can directly mark down the value and I can go next part. But I don't do that. I want all of your attention. Now you are telling Nayan, you are telling Priyan, Nayan, now you are telling Nayan, this value equals to mg. That's correct. This value is mg. Then you told, if I ask why you told this value is mg, you are telling there is no contact between object and the surface. That is also correct. But how you came to that conclusion by looking at the graph? How you can exactly tell that exactly at here there is no contact between object and the surface? How? Exactly at this point, when you look at your y-axis, what is the y value? 0. Because of that, this value is mg. Hands up who understand what I told? Okay. Important, write like this. Important, red color pen. When object loses the contact with the ground, the normal reaction force becomes 0. The normal reaction force becomes 0. Okay. Right. Okay. Okay. Case number, now what we already discussed, case number 4, case number 5. Case number 5. Case number 5. Case number 5. Alarm. Time boom. No. Alarm va. Case number 5. Right. Now, previous cases, you applied the external force vertically up and down. In this case, we are applying the external force inclined manner. Inclined manner. Inclined manner. Now, this is our object. External force is applied on this object. Capital F external force. Inclined, theta degree inclined to the horizontal. This angle of inclination is theta. What is theta? Angle of inclination. Inclination to the horizontal. To the horizontal. Now, I taught you in the class how to split a vector into two perpendicular components, right? I taught you, okay. Right, okay. Hands up who knows how to split a force into two perpendicular components. Okay. Simply I'll explain. Listen. Listen this. Okay, listen, okay, right. Listen, okay. 5 Newton force. Quickly, listen. This angle is 30. Listen. You know what is resultant force, right? You know what is resultant force? Now we can split this 5 Newton force into its two perpendicular components. That means, now temporarily understand, horizontal component. If we want to find the horizontal component of 5 Newton is 5 cos 30. 5 cos 30. Always the component touches the angle. Always the component touches the angle cos. 5 cos 30. The opposite perpendicular component is 5 sin 30. 5 sin 30. I'm not explaining how this came. Hands up temporarily who understand this one. Who can understand? Then please someone tell me, okay, now. This is 960. Okay, now tell me, Premji, what is this one? This component. 9 cos 60. 9 cos 60. Then Priyan, this one. Always the component touches the angle cos. 9 cos 60. Always the component which is not touches the angle sine. 9 sin 60. This component, our bro. Okay, our this bro. You, black bro. Fine, modified. Okay, no issue, right? Okay. Then can you please split this capital F force into two perpendicular components? What is the corresponding horizontal component? What is the corresponding horizontal component? F cos theta. What is the corresponding vertical component? F sin theta. F sin theta. What are the other forces acting on this object? Definitely its weight is mg downward direction. Normal reaction force capital R. If you split this capital F force into two perpendicular components, hereafter there is no capital F force. Do you understand? Instead of that capital F only, you mark two forces. Whenever these two exist, this one is not there. Whenever this one is there, these two not exist. Hands above, understand what I'm telling you? Understand? Now, resultant force me. Resultant. If you only mark this black color capital F, you should not mark these two. Instead of this black color capital F only, we are writing these two. If you write down these two forces, you don't mark this capital F force. That's the idea. Okay. Now my question is, how many vertical forces are there? How many vertical forces acting on the object? How many? Hands up forces 2. Hands up forces 3. Capital R, simple mg, F sine theta. Do you think this object is moving vertically? Do you think this object is moving vertically? No, right? Hands up who says this object is moving horizontally? Because of this capital F cos theta horizontal force, because there are other, when you look at the horizontal direction, there is only capital F cos theta force. Because of this external force, we learned when there is external force acting on the object, that object should move with an acceleration. Therefore, because of this capital F cos theta external force, your object is moving with an acceleration to the horizontal direction. But vertically, object is not moving vertically. Object is moving like this. There is no vertical motion. Therefore, vertical downward forces should be equal to vertical upward forces. Considering the vertical equilibrium, very important, equilibrium. What can you say about R? R equals vertically upward force R, vertical downward forces mg F sine theta. R equals mg plus F sine theta. Okay, listen. Okay, listen. Okay. Listen. This is one equation. Who got this idea? You can understand. At the same time, object accelerating to the horizontal direction. If an object accelerates to the horizontal direction, we can apply F equals ma to the horizontal direction. Applying F equals ma on the object to the horizontal direction. We want to mark the direction of the motion. Currently, because of this F cos theta force, object is moving horizontally right side. That is the F force, external force horizontal. F cos theta. As of the object acceleration is simply, then we can write acceleration of object equals F cos theta over lim. All these things that you learn now will be important when you do questions. Right? Normally, if I teach you F equals m, I don't need to explain what will happen to normal when the force is upward, when the force is down, when the force is inclined, because this is not to be taught in the syllabus. That means teachers to teach these things, but goodness. Okay, right on. Okay. Time is going quickly. Times are feeling time is going very slowly. Oh, very fast. And suppose says going quickly. One suppose time is going quick. Thank you. Time is going in normal. You know, yes, teacher. Recording. Okay. Write down the. January citation 4 hours. No change. The only I do 5 hours. First, it really hours. But if I does not have is and 5 hours. But even 100 at my list hours. Because then, but starting at 8, in this case, we do ask 10:30 the on you can't you maths fee by it's not because of it, TV everyone so so yeah how we call it, number 5 away okay, okay it's 12 o'clock but time doesn't wait I wait the problem okay now you did last now you now one for case number 6 case number 6 forces F1 another 2 in relation to this part simply case will have to come back. Understand. Yeah. Passport.